Welcome to Secret Squared. I'm Cassie Secret.
And I'm Megan Secret.
And we're identical twin math teachers.
Who are here to make math a little bit easier for you.
Now, today we're going to talk about something called combining like terms.
This is a foundational concept in algebra, and it's something you're going to see a lot of going forwards.
So let's dive in.
Before we start learning how to combine like terms, we actually have to know what like terms really means, and also what a term actually is.
Now, when we're talking about a term is going to be a product. It's going to be a product of numbers and variables.
And remember, product is a fancy way of saying multiplying, so they're saying you have some numbers, you have some variables, and you're multiplying them all together.
Yeah. Now, some examples of what terms, just individual terms, might look like.
So for example, one term, not a like term, just a term, might be something like 3x. When the number 3 is right next to that variable, that just means 3 is being multiplied with the x. They're being multiplied together, they're a product.
Now, something you could add, if you've ever seen that multiplication dot, you could add it there. However, us math people tend to not include it, but if you see a number and a variable next to each other, we imply that there is one there.
So besides 3x, it could also look something like this, 5x squared. That means the 5 is being multiplied with the x squared. And reminder, that exponent of 2, that is a fancy way of saying that x squared means it's x times the x. The 2 means there's two x's and it's all being multiplied together.
So that term is 5 being multiplied with x, being multiplied with another x.
Another term could look something like this, 16xy. So there is several variables, that is okay. All of it is being multiplied together. 16 is being multiplied with x, so it's being multiplied with y. Some non-examples, some things that might look like a term but technically aren't, would be something like this, 2x plus a y. Right here, 2x on its own is a term. It's 2 times the x. Where we run into the issue is we are now adding the y, we're not multiplying the y. So if we had something like 2xy, that would be a term. It's all being multiplied right here. This does not count as a term because we're adding instead of multiplying.
Now, something really important, not just in this video, but going forward, a very important mathematical term that a lot of people tend to forget about is something called the coefficient. Now, I just want to put a little note off to the side. When we're talking about a coefficient or coefficients, those are the numbers. Those are the numbers that are being multiplied in the front.
So for instance, in the list of all the examples, 3, that would be the coefficient. That's the number in the front being multiplied. We have the 5 as a coefficient, the 16 is a coefficient. Even in the non-example, technically 2 is the coefficient of the x because it's being multiplied with the x. And for that y on its own, it doesn't look like there's a coefficient. If there's not a number specifically written in front, we're going to assume it's a 1 because 1 times y is the same thing as just y.
A lot of times we tell our students if you don't see that coefficient in front, there's that invisible 1, and that's still one of the coefficients.
And a lot of people, you don't have to, but a lot of people do like to write the 1 in just so it's super clear what number is actually in the front.
Especially as you get started combining like terms, as you keep going, it might get more natural and you might decide not to include it.
So now that we've seen what a term is, now we're going to talk specifically about a like term. So what a like term is.
Now, something that is like is going to be similar. Like the two of us are twins, so we look alike.
So for a like term, that is having the same variable or variables and having the same exponents.
So what that means is as you were looking at the terms up above, every single one of the terms had like that x or that letter or the exponent that's part of it. Now, for those terms to be like or for them to be similar, they need to have that same variable or variables and the same exponent in common.
So for example, you might have something that looks like this.
If you have x, so x is a term just on its own, and if you have the term 2x, what you have to look at if you're deciding if it's a like term is you need to look at, let me highlight, you want to look at the letter portion.
So you can completely ignore the coefficient or the number in the front.
So what we see is both of them have the same variable, they both have the same letter, it's x, and the exponent has to match. Now, Meg, any ideas what exponent we have?
I know, there's nothing written down. So if there's no exponent written down, and remember the exponent is really this number, it's written slightly above the variable, that just means kind of like how the coefficient had that invisible 1, if it's not written, the exponent is similar where it has an invisible exponent of also 1. That just means there's only one x being multiplied.
Now again, us math people tend not to write it. However, if you're starting out and it's confusing you to not see it, feel free to add it. You are not correct or incorrect if you include it or don't. It's just personal preference. But now that we see the exponent, we see that they both match. They both have x and the exponent of 1. Now, a very important note, the number in front does not impact whether or not they're like terms.
You will use it when you're combining like terms, but you don't need it when you're deciding which terms are like and which terms go together. Don't need it at all.
Now, another example of some like terms, we could do negative 3x squared and we could do 6x squared.
Now, it looks a little bit different. One's a negative, one's a positive, but again, those are just the coefficients, so we don't really need to worry about those numbers right now.
We're just looking, they both have x and they both have that squared, so that means that they're like terms. Now, we could do something even more complicated
and this
here.
is probably one of the more complicated examples you will see.
You could do something like 4x squared y, 6x squared y, and negative 2x squared y.
Looking at it, it looks very overwhelming because there are a lot of numbers, there's several variables. The main thing you can do, first things first, you do not need to worry about the numbers in the fronts. The coefficients don't impact whether or not they're like terms.
I'm just looking at the chunk of variables and exponents. Now, each one of the terms has an x squared. It really matters that that squared here is always paired with the x beneath it, and it has the y next to it. Now, yes, it has several variables, but all of them match in all of the terms. So that means that they're like terms. Now, also, there are 3 terms here. You could have as many like terms as you want. I could have 2 like terms or 3. I could have 10 like terms.
As long as they all have the same variable chunk at the very end, they can be like terms.
Now, some non-examples. Now, that just means something that's not a like.
They look like they could be like terms, but they're not quite. So,
and we're picking examples that we tend to see our students struggle with when they're initially starting out.
So a common non-example, so it looks like it, but it's not like terms, is x squared and x. Both of them have the same variable, they both have an x. The problem is they don't have the same exponents. For instance, this one right here, it has an exponent of 2. The x on its own, it doesn't have an exponent, so we're going to assume it's a 1. So really, that has an exponent of 2, the other one has an exponent of 1. So they don't quite match because they have the same variable, both have x, they do not have the same exponent at all.
So that's something really important to look at. It might seem at first glance like they're like terms, but not necessarily. Another non-example that there might be,
and this is something you might see if there's several variables that pop up,
is 3ab and 6a. Now, you might say, oh, those look like terms because those a's both match and those a's both have an exponent of 1, which you're correct, those match up.
The problem is one of the terms has a b, so we have the b right here, but the other term, it doesn't have a b there. So even though they look similar, they have to be copy and paste the exact same variables. So this has an a and a b, so this also has to have an a and a b. Since it does not have both those variables, they're not like terms. They are both still terms, they're just not like terms, which means they're not quite matching. So now that we've talked about like terms and just what terms are, we can go a step further and talk about combining like terms. And I will say for combining like terms, the big steps, first step is deciding what like terms there are, like which terms go together. And after you do that, a lot of what combining like terms comes down to, it comes down to adding and subtracting.
Now, when we're asking ourselves, okay, how do we combine like terms? Again, it might sound overwhelming at first, but we just want to break it down. When we're talking about combining something, if you're combining something, you are either going to be talking about either you're going to add or you're going to subtract whatever you have.
And whether you add or subtract is based on the coefficients or the numbers in the front, whether they're positive or negative.
So positive means you're going to be adding everything together, and negative you're going to subtract. Now, so our steps, our very first step,
you're going to identify the like terms. So maybe there's 3 to 5 terms written down. You want to pause, look at all the different variables, and see which terms match up with another term.
Because again, we can only combine like terms. So we have to make sure we know what the like terms are to start. Now, our second step, we're going to add or subtract the coefficients of the like terms, which we'll see exactly what that looks like in another minute. So again, make sure you're looking for those coefficients for the like terms, and you're going to add and subtract the coefficients of the like terms. A big thing to note is as you are adding and subtracting the coefficients,
You do not want to change the variables or the exponents.
Now, that will especially make more sense once we get into it, but really what we're getting at is those like terms, they had that variable chunk or variable piece that matched, that made them like terms. Do not, do not, I'm even going to grab my red highlighter for this. Do not change the variables or the exponents.
When you are combining like terms, all you have to do with the variables is deciding, hey, which variables go together and make like terms. You do not have to change them, change the variable or the exponent whatsoever.
Now, we're going to go ahead and see this in our first example. Now, here's our first example.
So you might see, if it asks you to combine like terms, you might see something that looks like this. It says 18a squared minus 13a squared. The point of combining like terms is to take several terms, maybe two or more, and you want to bring it down and push it into as few terms as possible. Sometimes that's one term, it might still be more than one term, it just depends.
So really, we're going to simplify what we have here to make it smaller.
So first things first, to combine like terms, we actually have to have like terms.
And that's our step one, identify those like terms.
And both of these terms have an a squared. Same variable, same exponent, we are good to go.
Now, I will say, we are very big fans of if you are a color person, if
Yes.
you like highlighters, if you like color pencils, I have our students all the time, like, we'll grab that out and they will like mark it up. It can be very helpful, especially as you're starting out.
So now that we know, okay, these are like terms, so we can actually combine like terms, we're now going to add or subtract the coefficients of the like terms. So we want to look at the coefficients or the numbers in front of the variables. We have an 18. There's no sign in front of it, so we're going to assume it's positive, so a positive 18. And then the second term, we have really a negative 13. So what we're going to end up actually doing is we're going to do 18 minus 13, which ends up giving us a positive 5.
So what we're really doing here, and the way we like to think about it, is when we're combining like terms, I like to think about our terms as objects. Now, let's say instead of having an a squared, that I have a Snickers bar in front of me. And this 18a squared is telling me I have 18 Snickers bars.
And the minus 13 means you take 13 of those Snickers bars away.
So let's say I have 18 Snickers bars, and Megan comes over and takes 13 of those Snickers bars from me.
Total, we only end up with 5 left.
Now, what's really important is the object that we're dealing with. I still have Snickers bars. Even though she took them from me, I still have that object. So that object we're talking about is still the same a squared that we began with.
Right now, if we just leave it as 5, it's like 5 of what is left. That's why technically we are going to end up at the very end, still have the 5. That coefficient is now 5 from the old coefficients. We are going to tag on that a squared because that's what the previous variables were. Or that really means we have 5 of those Snickers bars or 5 of that specific object.
Yeah, so some of the most common mistakes that we tend to see is some people will try and take the 2 and the 2 and make the exponent a 4. Don't do that because, again, we had Snickers bars to start, we have Snickers bars at the end.
You do not need to touch the variables, they're just going to stay along for the ride.
Exactly. So this is going to be your finished final answer. Now, here's our second example. This time we decided to have a little bit more complex of a problem, but the steps are still the exact same.
So if you see 2 terms and you feel more comfortable with that, great. But even if you see like 5 or 6, don't freak out. If you can do combining like terms with 2 or 3 terms, you can do it with 4 or more.
Yeah. So first step is you want to identify or find your like terms. So again, like terms have the same variable. Now, that doesn't really help here because all of these have x's.
So that's when you really are going to end up looking at what the exponent is.
So matching variable and exponent, I like to start with whatever the first term is. I'll look at that. That has an x, and it has that invisible exponent of 1 that we can go ahead and add. So you're looking to see if anything else has an x, which that term on the very end, that negative 3x does.
And then after that, you can look at, okay, which terms do not have any highlight or we haven't dealt with yet. In this case, we have an x squared, and then you want to look at all of the rest of the terms and see if there's any other x squareds. In this case, there is another x squared right here. I will say sometimes maybe there's an x squared right here. Maybe this one wasn't an x squared. Maybe it was an x to the third power or something else. Not all of the terms will always pair up perfectly. It just kind of depends.
So if something doesn't have a matching like term, don't worry about it. You just keep that as part of the problem and you don't change it.
And
Now,
found all the like terms. Now we're going to focus on one batch of like terms at a time. So maybe the yellow and then the green.
so if we start with our terms that we highlighted in yellow, we have 2x and negative 3x. I'll just go ahead and write that below. We had 2x and minus 3x.
So this kind of breaks the problem into a smaller problem where now you're only dealing with 2 terms instead of all 4 terms.
Now, again, it's that idea of when you're combining like terms, you're just combining the numbers that are in front. So I have 2 and I have negative 3. So if you do 2 minus 3, you're going to get negative 1. Now, if you're someone where those negatives tend to throw you off, I always encourage people to think about money. So if I have $2 and I owe her, that's why it's negative, I owe her $3.
Not only do you not have money, you owe the other person exactly
$1.
$1.
So again, if negatives are something that throws you, I really encourage you to think about money. So we get that negative 1 in front,
And then we still have to tag on the x just to make it clear it's negative 1 of that x.
now something I just want to point out, you could put, or you could just put negative x. You do not have to write the 1 in front. That's a very common question that people ask. It really is just personal preference. If you like seeing the 1, include it. If you don't have to.
We
But
assume that if there's not a coefficient, we're assuming it's a 1, but in this case there is still that negative because we need that negative there.
yeah, so again, we took those 2 terms and we went and combined them.
Now
But
switching gears to look at the green terms, so we have that 4x squared plus the 6x squared.
so we're just bringing those from above, bringing them down. But we first noticed they are those like terms. They have the x squared chunk on it.
And the nice thing is that people will probably be more comfortable with is both of the coefficients are positive. So we have the like terms, both x squared. Now we're looking at the coefficients or the numbers in front. This problem really turns into asking you 4 plus 6. That does give you a 10. And then that variable is going to tag on. It is still 10 of the x squared.
Remember,
it's saying,
don't change
yes,
the variable
still
or
x
the
squared.
exponent.
It's saying, hey, you have 4x squareds, and then now you have 6
More
more.
of them.
In total, you have 10 of the x squareds. And then at the very end, we really took this problem and broke it up into the yellow and the green parts. So now we're going to put together our answers. So we have that negative 1x, and plus we have a 10x squared. It also, again, could have been written like this, negative x plus 10x squared.
Now, something else I do want to point out, depending on your teacher, you might have it where they want you to write it in what's called standard form. And in that case, or you'll see in math, there's a lot of different ways to write the same answer. A lot of times us math people really like to put the bigger exponent in the front. It just feels right.
So standard form means put the highest variable with the highest exponent on the left side, and then it kind of counts downwards.
And so that's probably the most common way that you're going to see your answer. Now, if you have one of these other versions, you are not wrong. You just wrote it a little bit different.
It just depends. Some teachers, or depending where you are in your math journey, they might specify they want you to put it into standard form. Standard form means the highest exponent to the lowest exponents.
Exactly. So that would be your final, finished, done answer for this problem.
Okay, for our third example, we might have something that looks like 4x squared plus a 9x. First things first, we have to decide, are these like terms? So we're going to look at both the variables
and the exponent.
So both of them have an x. Great. Problem is, when we look at the exponent, this one has a 2 as your exponent. The one on the right, that actually only has a 1 as your exponent. So they aren't like terms because the variables and the exponents don't match. So this is actually the furthest you can go with this problem.
This is a problem that you are very likely to see in class where your teacher gives it to you because they're trying to trick you.
Because at a certain point, you get so used to combining like terms, you're going to want to look at the 4 and the 9, and
just
you're going to
add
say 13x to some power, and you're going to want to keep going. But technically, you actually can't.
You can only combine like terms if you have
like terms. And actually, this is really similar to where we ended for the last problem.
For the last problem, we had an x squared. We had an x squared, and we also had an x. Those terms, the reason we didn't keep going and combine them further is those exponents didn't match up. Now, just like that other problem where we couldn't keep going, you can't keep going here.
And you actually can't even really start the problem because there's not like terms to work with.
So if you were to see a problem like this, you're just gonna box the question. That is your
final
answer. You can't combine it. If you want to make a little note, they are not like terms. They are not like terms, so we can't, and I'm going to underline that, we can't combine them. So be really careful. It's something to be on the lookout for. Combine them.
So for our final example, we're going to have one of the hardest questions we're going to see. So in this case, we have, instead of just 2 or 4 terms, we actually have 5 terms. Even though there are way more terms, we're going to start with the same earlier steps. We're going to start with just looking for which terms are like terms, so which terms have matching variables and exponents. Like Cassie said earlier, I like to go left to right just to make it easier. So I have an x, y squared. So I'm going to look at all of the rest of the terms to see, do any of them, because maybe they don't, do any of them have an x, y squared? So looking through, that has an x squared,
But
not going to work.
oh, that really looks like it though.
It really does look like it.
Because I see an x and a y and a squared, but
It does matter which variable has the 2.
so for the first one, that squared has to go with the y. The second one, the squared goes with the x.
So
They
it
are
floats.
different.
It's like they have the same ingredients, they're just put together a little bit
in the wrong order.
So this one doesn't match, not like terms. We look at this one, okay, it has an x with a 1 as the exponent, and it has the y squared, so those are in fact like terms. Then we keep looking, same thing, that's an x squared, not just an x, and this doesn't even have a y, it's just an x on its own.
So from there, we found ones that are like terms. I like to just keep going in the beginning, find as many as you can. So starting on our next one with that x squared y, we want to see if we have anything else that has the x squared and the y with it.
So let's see, this term's already been used. This term is also an x squared and a y. So this is a like term. Those blue terms match up. Looking at the last term though, just an x doesn't even have a y. And actually, this is the last term standing. It doesn't have anything else it could be a like term with. That is okay. Sometimes there are terms that don't really match up with anything else.
And if that happens, I'm just going to go ahead. I'm going to give it its own color. It will be fun little green over there. It doesn't have any buddies, so you're just not going to change it. You'll include it in your answer, just tag it on to the very end.
So from there, you could start with the yellows, the blues, up to you. I'm just going to start with the yellows. So let's put these two together. So we have the 12xy squared minus a 4xy squared.
Again, just taking a set of like terms that we see, we're going to go ahead and just combine those off to the side.
And we know they're like terms, the variables and exponents match. So this becomes 12 minus 4. And so really we have 8. And then we still need to have those variables, the x, y squared.
Don't change the variable or the exponent.
Anything
That
variables
is
or exponents in any of these problems. It's great.
that
have
is
to
the
do
thing
it.
that throws people off the most, so just be super careful.
So the yellow chunk is done. Let's look at the blue.
Our next one, taking those blue terms, we have 3x squared y, and we have plus x squared y. Now, just another little reminder, we threw it in there. If you're looking at those coefficients, those are the numbers in front. I have a 3, but I don't see a number in front of there. So if you don't have anything, that just means there's that invisible 1 that's written in front. Us math people tend not to write it. Again, if you like to include it, feel free to write it whenever. You're not wrong for adding it.
And then from here, you're like, okay, I have a 3 as one coefficient. I have a 1 as the other coefficient. 3 plus 1 gives you 4.
So we're going to have 4 and keep the variables and exponents the same.
Do not have to change them.
Don't change them. So that's going to keep x squared y. So that is now the second chunk. And then just for the very last one, just to bring it down so it doesn't feel left out, we still have that x. We did not have to do anything to it because it didn't have any like terms to combine with. It didn't have any friends.
And then at the end, it's really us putting all the little pieces together. So the beginning, the 2 yellow chunks really turned into our 8xy squared. Oops. There we go. Then our 2 blue terms, the 3x squared y and the x squared y, that turned into a positive 4x squared y. And then last thing, we had the green chunk. We didn't have to do any math with it, but we still need to have it included in the end. So we end up with a plus x.
And again, from here, these 3 terms, you cannot combine them anymore because none of these are like terms. It's really important to be able to figure out when to keep going and when to stop.
So even though there are 3 terms right here and we haven't had one that ends with 3 terms, that could happen. It just really depends on how many like terms there are and how many different like terms there are.
So that is your final answer for this problem. Thanks
Thanks
for
for
watching.
watching.
If you enjoyed this video, please like and subscribe.
If you have any other topics you'd want us to cover in later videos, leave them in the comments below.
We'll
We'll
see
see
you
you
next
next
time.
time.